This is 404 loading, where I document what I am learning in cybersecurity and networking through practical labs. In this video, we will configure OSPF dynamic routing between two routers in Cisco Packet Tracer and test how routers automatically exchange routes between networks. Let's first set the topology. First, I am placing two Cisco router 1841. Go to router 0, physical, zoom in a little bit, then switch it off. Take WIC1T and WIC2T. To use serial connection, the router needs WIC serial models installed in physically. Without these modules, serial interfaces won't be available. I am switching it on. Next, in router 1, we'll do the similar thing. Power off, WIC1T and WIC2T. Power it on. Both routers need serial interfaces because they will communicate over a WAN link. Let's choose the wire, connecting wire. We are selecting serial DCE. So serial 0/0/0 to serial 0/1/0. Now connecting both routers using a serial DCE cable. The DCE side provides clocking for the serial connection. Let's connect to PC here, one PC here and another PC here. Copper crossover cable is needed. First Ethernet. Oh, sorry. Chose the wrong one. Next, connecting PCs for end-to-end connectivity testing. Now let's configure the router 0. Go to the CLI, N, En, enable, conft int f0/0, no shut, IP add 10.0.0.1 255.240.0.0. Now configuring the local LAN interface on router 0. This PC address will act as the default gateway for devices in network 10. The no shutdown command activates the interface because router interfaces are disabled by default. Next, int s 0/0/0 clock rate 64000, no shut, IP address now 192.168.0.1 255.255.255.0. Now configuring the serial interface between both routers. Since this router is connected through the DCE side, clock rate must be configured manually. The 192.168.0.1 network will be used for router to router communication. Next, configure router 1. CLI, no. Enable config t int f0/0, no shut, IP at 20.0.0.1 255.0. Sorry, 255.240.0.0. Now configuring the LAN interface on router 1. This becomes the gateway for devices in network 20. Next, int s0 0/1/0, no shutdown, IP at 192.168.0.2 255.255.255.0, assigning IP address to the serial interface connected to router 0. Now let's configure the OSPF. So let's go to the router 0. Exit router OSPF question mark. The router OSPF question mark I gave because of what does this command needs more? It needs process ID. So let's write router OSPF 1. Now enabling OSPF on router 0. OSPF is a dynamic routing protocol, which means routers automatically learn and exchange routes instead of manually configuring static routes, as I did in previous videos. Network 10.0.0.0 0.15.255.255 area 0. This network statement tells OSPF to advertise the LAN network connected to router 0. The wildcard mask here is 0.15.255.255 determines which interfaces participate in OSPF. Next, network 192.168.0.0.0.255 area 0. Now advertising the serial network used between routers. Area 0 is the backbone area in OSPF and is required for proper route exchange. Now let's go to the router 1. Exit router OSPF 2. Now enabling OSPF on router 1. The process ID can be different on each router because it only has a local significance. Network 20.0.0.0 0.15.255.255 area 0. advertising router 1 LAN network into OSPF. Next, network 192.168.0.0.0.0.255 area R0. Now both routers share the same OSPF enabled serial network. Control Z, SH, IP, root. Checking the routing table on router 1. Routes are learned through OSPF appeared with the letter O. This confirms both routers are successfully exchanging uh, routing information. Let's go to the router 0 and do the same thing. Control Z, show IP route. Here it is with the letter O. Verifying OSPF learned routes on router 0. Now we have to next configure the PCs. Next, configure PCs. Go to the PC 0, desktop, IP configuration, IP 10.0.0.2, tab. Default gateway will be 10.0.0.1. Let's change the subnet mask also to 55.240.0.0. Assigning IP address and default gateway to PC 0. Now set PC 1's IP address, desktop, IP configuration 20.0.0.2, 255.240.0.0, 20.0.0.1. Assigning IP address and default gateway to PC 1. So let's go to the PC 0. Command prompt ping 20.0.0.2. Now testing connectivity between both networks. First one, the request amount for ARP resolution. So if OSP routing is working correctly, the ping should success and it is successful ping. Let's go to the router 0. Config int s0/0/0 IP OSPF hello interval question mark. So for hello interval, we need to give another parameter which is in second. So why I am doing this? Because of now checking the OSPF hello interval. Hello packets are used by routers to maintain neighbor relationships. So let's check that and set that. So IP OSPF hello interval. Let's give 11. Control Z. show IP route. Changing the hello interval from 10 seconds to 11 seconds. So OSPF neighbors must have matching hello timers. A mismatch can break adjacency and stop root exchange. That's why the interface down or detached. So again, let's do the show IP route. Now the OSPF one vanished because the mismatch break the adjacency and stop root exchange. Previously, the OSPF one is still visible. Now it's vanished. Basically, by default, every router has a hello interval for 10 seconds. I changed that 10 seconds into 11 seconds. That's why another router has 10 seconds for hello interval and this router has 11 seconds for hello interval. That mismatch is happening. So let's restore the hello interval back to default. Const int is 0/0/0 IP OSPF hello interval 10. So restored the hello interval back to default. Now Control Z. Let's wait for a bit. See the loading to full loading done. Let's see it happened already or not. Show IP route. Yes, the OSPF one back in the table. OSPF neighbor relationship now recovered. The routing table again, that's why the routing table again displaying the OSPF learn routes. So that's it for this lab. This covered OSPF dynamic routing, automatic route exchange, and hello interval how mismatches affect neighbor relationships between routers. More lab as I continue to learning. So keep learning, take care, bye.